Alright, here I am in Genius, and we're going to enter our data now. Now, hopefully you have received your data from Dr. Kiner or Professor Houston, and you have those files on your computer. That's what I am assuming. And what you need to do is drag and drop those files here into this space. Here it says drag and drop file or make new folder to start your next project. All you really have to do, you can make a folder if you want, but all you have to really do is drag and drop your files here. So I have them off screen here, and I am going to drag and drop my files in there, and I am going to do it here. Now, where do I want to put it? Local or something like that. I will go ahead and make a new folder, and I'm just going to call it demo, like that, and I'm going to go OK. And that's where I am going to put all of my files. And let's see, it says what type of import. Actually, that's fine. Yeah, let's leave this as unformatted and go use for all. How do you want to store these? FastA, auto detect. I don't know if I want to do this. Let's see. Storing the sequences. We can create a list. I think that will help. Now here we get a choice to replace invalid residues with ambiguities, or remove invalid residues, or discard. So this is a question here of whether or not we want to remove these invalid. I think we probably ought to learn to do this by hand, so I am not going to do that. I'm just going to say with ambiguity. I'm going to leave it at the default. I'm going to apply it to all, and I'm going to go OK. And how do you want to store the inner? And I'm going to continue to create a list. All right, and here we go. And so here I have our data. And as you can see, it's showing us our sequence here, and we have all of these. So nucleotide sequences, and what it's doing here, when I hit this one on the top here, it's showing us the various sequences that are the same, and we're actually getting to see how they compare. Their lengths are different, of course, and you're kind of getting to see that here. Now, let's see, we can hit wrap. And now we get to see the letters. So that was kind of, when we don't do the wrap, we're kind of looking at them big picture from far away, far out. We're getting to compare their lengths. So you get to see their lengths, the length of them. All right, that's kind of why you do without it. But I like the wrap. And here we get to see them, and you get to actually see it. Now, notice these ends at the beginning. A lot of time when you do sequencing, or actually you should say all the time, the ends, the beginning and the end, are going to have ends in it. There may be ends, which, if I didn't say it already, ends are when you do not know what letter it is. All right, so it's ambiguous, so it's an end. All right, and we may have to go and trim these a little to get those out. We'll see how this works out. So notice over here there's some cool things you can do. You can switch and see the complement of these. All right. You can translate to amino acids. All right. Now it doesn't do it. You'd have to zoom in and do some other things to actually see the letters. But what I like here is you can find out where the restriction sites are. So where restriction enzymes might cut this sequence. All right. And what restriction enzyme it is. So that's a pretty cool feature here. All right, now we don't care about circularizing and not bacteria. So let's see, a description. No, we don't need that. But I do like the wrap part. Okay, so just showing you what's going on, and we can actually change the colors. I kind of like them a little brighter myself, and with some darkness. I kind of like that. Oh, that doesn't look good here though, but on a lot of programs I'll do it like that. Let's see what this one, a little too bright there. I guess maybe that is the best one, or one of these first two. Alright, so you can see here, we can see the letters and color coded. Some people don't like color coding and they want to go back to the black and white. It's dependent on you. And also the size makes a difference too. So this is a way to see your sequences all lined up. And of course, these are not aligned actually. You would like to do something like an alignment, which will actually look at the letters. And if those of you in bioinformatics, of course, know what I'm talking about when I say an alignment, we could do a consensus then and do some interesting things there. We could also run these two at a time through dot plot, and we could compare and come up with our own alignments kind of by eye instead of by computer program. All right, so this is the first part. I want you to see this. Let's look at a few more of these. Here we get to see the amino acid sequences that are translated. Let's see what we get when we hit wrap on that one. It still shows the line, so the idea here is I don't know if it was translating there for us or not. Here is your chromatogram. Now this we'll stop and talk about for just a second, and here are those ends down here, and see how the lines, it's ambiguous what the read is. So in other words, a read is this little peak here, and if it's very strong, for instance, very strong for A right here, and so it's got these three little A peaks. It's a pretty good sign that that is. And as long as it has a peak and it's clear and there is not another peak, it's a perfectly good read. It can be tiny peaks, but like I said, the thing you don't want is an ambiguous one where you get over here where here, like right here, it's red and yellow, so you don't really know what it is. Here it's both, and so you ambiguous reads you do not like. We get some ambiguity here a little bit, but it's decided to tell us that right here what it is anyhow. It looks like do we have any ends there? No, it makes the decision for us. I would be suspect of this, but obviously their sequencing wasn't, and they say that's what this is. That one, I would be very suspicious of that piece right there. But otherwise, you know, this looks pretty good. And you can see here that we've got our chromatogram, and this is basically what the spectral analysis of the sequence is as it moves along the sequence. And yeah, this is a pretty good sequence. Now down here, of course, it gets bad. Towards the end, it's always going to be bad, and towards the beginning. And we'll have to trim that off probably. You don't have to, but as a general rule, you would. You could leave it in if you just want to have a space holder for that nucleotide. You could leave it there as a space holder to help with alignment, but if you don't care if most of your alignment is coming from the sequence in the middle, the ends don't matter, which ours probably don't. We just care about the middle part, so trimming it is just fine. Alright, so I wanted to show you this and how to load your sequences. Let's see, is there anything else we need to look at here? And yes, I am using, this is much clearer. It gives you the actual printout. We can see up close. I should have gone to this instead of the viewer. This is actually the printout for this. Alright, and let's go to another one. Another view of this. Again, different one. Yeah, okay, we've seen every type of file. That's what I wanted to make for sure. So this is it for the viewer. So we're looking at Genius, and we're looking at the viewer so we can figure out how this works. This is basically what you need to do to use the viewer. Remember, just drag and drop your files in, and then it will give you a list of these, and you can click on them. Here we can zoom in, so yes, I should show you that. And now if you've never seen this, this is showing the strength. So this one has some ambiguity. This one is G, which is kind of the yellow looking one, the yellow looking line on the graph, and it's not 100%, so you get a little bleed off on this side and a little bleed off on the green T, and then there's another G over here, but there's also this one here, a blue C that's bleeding in a little. So it's not 100%, but it's pretty strong to be a G, and so it shows you a larger G. When it's really strong, it gives you an A, and as you can see, here we have pretty high peaks, and it's giving us this. And I've forgotten the name of this style of representation, but there is a fancy word for it, so you can do it that way. This is just the text view, so you can go see your sequence. This is something called the FileUp format right here, and there are lots of different versions of the FileUp format. I have my own that I've created, so but the FileUp, it's just a little bit letter, and it's usually small letters when you do FileUp, and it gives you some other information here. And here's your standard FASTA. All right. Now this is as an AB1 file. This is a FASTA file. All right. And it is one, and yes, they formatted it with the 70 letters, and they put our greater than sign here, and they still didn't tell us that much about it. If I were doing this, I would give a better description up here. But this is the idea. So then we have lineage. We haven't done that part yet. We'll go find out if it's related to something in a little bit. And nothing here. This is just time and stuff like that. And that's it for format and viewing your sequences and different various sequence files.